Everyone, Mr. Rubo here. Today we are looking at 3.10, which is trig equations and inequalities. We'll focus just on trig equations. We're going to look at these two equations real quick and just think about what their answers are. We'll actually start with equation 2 here because we just talked about inverses. So let's kind of review this. So if you say sine inverse of 1/2 equals x and you want to solve for x, we're going to say, okay, it's in quadrant 1 because it's a positive sign, opposite over hypotenuse, so 1/2. And this angle that would give it to us is pi6. So we get this one lovely answer. When we go to the first equation, though, sine of x equals 1/2, well, I can definitely use that same exact triangle I just came up with and get an answer of pi6. But because there's no restrictions on sine, when it's just sine, right? Inverse sine has the restrictions, regular old sine does not. I could have another triangle in quadrant 2 that has those same dimensions, right? Those same ratios of sides. But now we're in quadrant 2, which if I measure from standard position would give me 5 pi over 6. So you can see already we have a difference between these two when they look very, very similar, right? So this is just a thing to consider, where inverses, because of the restricted domain, you're pretty much always going to have one answer, right? Where for regular sines, regular cosines, like the non-inverse ones, these ones, multiple answers, right? You could have multiple triangles that would give us the same values. So because of that, we're going to talk about actually finding the general solution. So if we think about the equation 1 that we just did, came up with 2 answers. But if you really think about it, I can come up with more, because if I take that answer of pi6 and let's say add the period, which really, get a common denominator, just as kind of a review, so it's 12 pi over 6. I get 13 pi over 6, and guess what? If you type sine of 13 pi over 6 in a calculator, you get in 1/2, okay? And that would also be true for the 5 pi over 6, right? If I do 5 pi over 6 plus 2 pi, and again, same common denominator, so 12 pi over 6 is the same as 2 pi, and you get 17 pi over 6. There's another answer. So what this is telling us is we can just keep rotating around the unit circle to create an infinite amount of angles that when we do the sine of it, it'll give us 1/2. So the way we do this is we get those answers, right? So we do our triangles as we need, right? This one I'm going to do kind of quick because I've already done it. You're going to draw both triangles. You're going to figure out both these angles. So we got one angle was pi6, and then we got one angle was 5 pi 6. But to take into account the infinite amount of answers, we're going to put plus the period. So the standard period is 2 pi. And then we're going to throw a k on there, meaning we can add as many 2 pi's as we want, or if we make k negative, subtract as many. So we're going to do that for both of the answers. And then we also are going to throw on at the end that k is an integer, which the shorthand of it, I mean, you could 100% just write it out, but you can also say k is an element of the integers, which is this symbols here. So it's k with like a weird looking e, and then it's z with an extra line there. So this is another way of just saying k is an integer. And you could also just write it out in words. You don't have to necessarily use the symbols, but you do have to define k as an integer. Okay, because you can't say k is like 0.5. It's got to be k is whole numbers, either positive or negative. Okay. Here we go with cosine x equals 1/2. Same idea, but now cosine is positive in quadrant 1. So this is 1, this is 2, which tells you that, okay, my angle is pi thirds, right? But then you could also have a positive cosine in quadrant 4. So now this one, if I go positive, I'm going to say, okay, that's 5 pi thirds as my angle. So I would get x equals pi thirds and x equals 5 pi thirds. Okay. And then again, because I want all of the answers, I'm going to say plus 2 pi k, plus 2 pi k, and in each case, say k is an integer. K is always an integer for these problems. But yeah, there you go. Got to throw on that 2 pi k for these general solutions to get all of the answers. Okay. Thanks for watching. Have a good day.